Hey everyone, and welcome to Pomodoro Joe for Tuesday, January 3rd, 2023. Let's see what problem we have in store today. All right, so today's problem was LeetCode 944. Delete columns to make sorted. It's an easy problem, and the description says, you are given an array of n strings, strs, all of the same length. The strings can be arranged such that there is one on each line, making a grid, for example, and then they have this example ABC, BCE, and CAE. So one string per line, and you have this sort of grid. You want to delete the columns that are not sorted lexicographically. Okay, so the columns that are not in alphabetical order. In the above example, 0 index columns ABC, blah, blah, blah. So you would delete column 1. Okay, that's BCA. Return the number of columns that you will delete. Oh, all right. So we basically go through, find the columns, find which ones are not sorted alphabetically, and increment some counter, and we'll return the total count. And we have some constraints. The good news is all of the string lengths, I think it said they're all the same. Yeah, it says here they're all the same length. And they're all going to be lowercase English letters, so pretty straightforward actually. All right, so we'll take the straightforward path first, and then we will try the Pythonic path that's a little bit more convoluted, but should be faster and more Pythonic. All right, starting the Pomodoro timer now, 25 minutes, and here we go. So essentially we just want to go down each column in order. So we'll have some result, we'll start it at 0, and at the end we will return our result. And that's just going to be a count of all the columns that are not in alphabetical order. So basically we want to go for index I in range for the length of our strings, or our first string here. So let me actually do this. Let me do a string length, or I'll call it length string so it's not confusing. So the length of any given string is going to be the length of the strings at 0, because they're all the same length. So I get my first string, find its length. And then, let's see, I'll call this like string count equals length of all the strings. So that's going to be how many strings do we have total. All right. So now for index in range length of each string. So this is going to basically break these strings into columns. So this I is the index of the character in the string, which represents the column. Then we just have to make sure that all the columns are alphabetical, so, or all the characters in that column. So we'll just go through each string one at a time. So for S in strings, let's see. No, we can either keep track of the previous value, or we can actually do a J index. So we'll do that in range string count. So J gives us the string, I gives us the column. And if we want to do this a little bit smarter, we can start at index 1 and go to string count. So that way we're basically just looking back at the previous string to see. So we'll basically start at index 2 here, and we'll say, is the B greater than or equal to A? If it isn't, then we say return false. If it is, then we move on. It's pretty simple. All right, so now we have to say if the string at J column I is less than the string at J minus 1 column I, Now we're not alphabetical, so we just result plus 1. And we break out of this loop. We don't need to keep going through this column. We're done because we already determined it's not alphabetical. And that should actually be it. Let's run that, see how we do. And we pass. So again, we're basically just going through every character in the string and then comparing each string character at that index. So this gives us our column and this gives us our row. And we'll submit that, see how well we do. And we pass. It doesn't do a great job. It only beats 20% of other submissions in terms of runtime, and it only beats 25% in terms of memory. Not great. So what are some things that we can do to improve this? Well, we could, instead of going through each index j, we could keep track of what was the previous value. That might make a little bit difference. We can try that. Actually, let's try that. So prev character equals, start it as none. And then in that case, we actually do need to go through every single column or every single string. So if we don't have a previous character, this is going to be the first column. Then we just say, actually, and this is going to be for a string in each string. And we're not going to go through range of string counts. We're just going to go through the strings directly. So we're just going to say for each string in our strings, if we don't have a previous character, then our previous character is going to be equal to this string at index I. Otherwise, and actually we'll just do a continue. It's a little bit easier to do a continue than an else. Otherwise, we check to see if our s at I, if it's less than our previous character. We increment our result and we break, similar to how we did this before. Otherwise, we're going to set our previous character equal to s at I. Okay, hopefully this still works. Hopefully I didn't make any typos. Still works. Let's see if that improves our performance at all. A little bit. Little improvement in runtime and about the same, actually exactly the same in terms of memory. All right, now we'll jump into the tricky Pythonic way. This is what you've been waiting for. I'm going to break this out, make it a little bit clearer. There will be faster ways to do this, but I want to make this clear. So we'll start it by breaking this out into columns. So we're going to get columns. How do we get the columns? We use the zip function, and we pass in our strings. So this gives us all of our columns. Now we can say for each column in our columns. So this is, zip is essentially going through each of these strings one by one, grabbing each element and zipping it together with the other elements, the other first elements, the other second elements, the other third elements. So that's going to give us our columns. And then for each column in our columns, how do we know if they're sorted in alphabetical order? Well, here's another simple, quick way you can do it. You can say if the column, so we're going to sort the column. So if the sorted column doesn't equal our actual column, but we can't just compare, so this sorted is going to return an array. We want to break this into an array as well, because we can't compare the array to a string. So we have to basically create a list out of this column. So if our sorted column doesn't match just our column as it would be in a list, well, then we know they're not in the same order. They're not, this column is not alphabetical order because the sorted order changed this column. So we do our result plus equals 1, and then at the very end we will return our result. And of course I need to actually have a result up here. initialize to 0. So we have a result. We break our strings into columns. Then for each column, we check to see if it's alphabetical by checking the sorted version of the column against the natural version of the column. If they don't match, then the natural version of the column is not alphabetical. And that should do it. It's a little bit less code. This zip should make things pretty fast. So let's give that a shot. Whoa, significant improvement in runtime, 97.6%. So this beats 97% of other runtimes. It doesn't do as great with memory. It's about the same memory footprint as our other, but I take runtime over memory most days. So that should cover it. That's about it. All right. Short and sweet. Hope you enjoyed that. Hope you learned something. I suggest that you go give this a shot on your own. And then when you're done, go out and write some great code.